ceremonial name for this topic is called software development project management. There may be other software related projects like maintenance and data migration or migration to new version, which is more maintenance oriented, but in this particular case we will pay most of our attention to the development process. And before we go into complicated ideas, there are two different schools of thought how you look on reality. There is always, especially when you work in quality assurance related things, when quality in theory may be improved till to infinity, only you will need to spend more and more time and effort to improve them, so it is not technically and financially feasible. And similarly about project management, one school of thought may be that reality is always much worse, or at least a little bit worse than good theory predicts or tells or says about these things. And then you may hear from other teachers, other colleagues that every time you do not explicitly do management, you should be feeling ashamed and guilty about this, etc. I don't think so. I think that everything what happens in reality is, let's say, legal and good enough, and so that is just reality. And the important part of reality is that there are many projects and software development projects that do not use explicit project management, and these projects are just you write code, you debug, you test, and you don't have any explicit management. You can call it in different ways, like code and fix, cowboy coding, just hacking, and I don't lose time for planning, etc. And it is very okay, and it actually works either for solo projects where you are only developer, maybe even you're only user for this software, and it is very okay. And it may also work in small, well-established, experienced teams, but it doesn't work well in larger teams where you have to align your plans and what everybody will do with everybody else. And this visualization here is not for software development project, it's from real engineering like building and construction, but everybody who can analyze what he or she is seeing probably thinks that it is a case of not the most efficient teamwork. And question may arise why it happens. And it happens for two reasons. One reason is very easy to understand, that not every work is easily scalable. For example, in this case, you could give ladder and traffic light to fix to every member in this team, but it will not improve anything much because probability is very high that they need only one traffic light to prepare for this construction work in one particular case. So, and that means that there are some jobs like dependencies in your software development. Sometimes before you can scale up your teamwork, you have to do some preparation. That's something like I have seen for Microsoft Windows. So, because of these dependencies, not everything is easily scaled up, that you can involve more and more persons in the project and they just easily will distribute workload on different tasks and do it. And when we look particularly for software development projects, there are quite a lot of these dependencies which have to be done before something else has to be done. And if this thing what have to be done before that is not easily scalable, then of course adding more people to the team do not make this team more productive, because if you have more technical mindset, not like a people-oriented managerial mindset, remember your activity about concurrent execution of threads in your Java application. Adding more threads to do some task will not make them run faster if most of these threads will just wait in queue. And of course there are physical limits, particularly for your multi-thread programming, is that you still run your program on the same physical environment on the same computer. So only thing you can actually increase this concurrent programming is to use better, to utilize better available resources. And it's similar to people-oriented tasks. So if you have some other constraints and physical limits, how fast you can do some things, how can you scale these things up, then adding more people to the team will not make it more productive. So you will just add more people like these concurrent threads which will be waiting and doing nothing. And so that's the most important thing, that when you start working in a team, your biggest enemy and headaches are dependencies. That if you have to do something before something else, and what you need to do before that is not easily scalable, so you can't just split it into equal part for everybody, then you will have a problem with this workload distribution between team members, because not everybody will get something useful to do. And particularly for software development projects, one of first scientists who studied this phenomena was Fred Brooks. He worked for IBM in large-scale projects, and he wrote a book called The Mythical Man-Months in 1975, where short slogan for this book was following: that if you add more people to the project which is already late, then this project will become even later. Why? Because particularly for software development, it is it requires skills and knowledge, and if you add more people who are not skilled and trained enough to work in particular project, what actually happens is that existing team members become less productive because they need to introduce these new team members to this project. But new team members are not productive yet because they don't know enough to be productive and to contribute to this project. So this means when you have more persons in a team, initially productivity goes down. Another thing what he also paid attention quite a lot is that particularly for software development environment or development environment, testing environment is also very important, because in difference with simple equipment, this environment also adds quite a lot of configuration problems, that something fails, something doesn't work, etc., just because of different configuration and different environment. And then after that, many other different management approaches were introduced, and most of them are shown here on this time axis. So y-axis do not have any particular meaning. It is just used to show these labels for particular project management. So what was important to know is that initially software was developed in the same approach as buildings, ships, cars and bridges or whatever. So they were developed in a so-called, what is today called waterfall model, where you start with plan, then you go into design. I will tell it more details later. So you always just go forward, but later, starting with 1980s and forward, software development became quite different from development of tangible things, because with modern development environments you can easily change software. So already built building or bridge cannot be changed very easily, but with proper support of development tools, software can be changed much more easier, and therefore different kind of iterative approaches were introduced. First was spiral model, then rapid application development, then agile process, and Scrum as one of most popular iterative approaches, etc. And if we go in details are following. So waterfall model is very similar to developing tangible things, like for normal engineering of tangible things. So your lifeline of the project goes only forward, and you start with collecting requirements for your software, then you create design of this software, about architecture, about data flows and how it works, like different kind of like deployment approaches, etc., algorithmic details, etc. Then you implement it, then you verify it. So because waterfall is quite old approach, at that time testing was not invented as a term yet. It was called verification, which comes from science and mathematics, but what they mean with verification today is called testing. And then you have maintenance of this project. And why it's called waterfall? Because idea here is following, that you do not go to the next stage before first stage is completed, and you never go back. So time here flows from left to right, and dependencies goes from top to bottom. As you can see here, there is actually a little bit of overlap. And what this overlap means, this means one very important feature is scalability of tasks and management. And so here is number of involved people and project, and here is time. And as I told you initially, number of involved people in project is very small because of these dependencies, how you start this project. And you have to prepare environment, you have to prepare many things, and therefore you always start with small number of people, and then you can ramp it up. You can prepare environment, you can prepare tasks, and you can involve more and more people in the project. So it looks like exponential growth, but of course it doesn't grow exponentially infinitely. It's actually logistic curve. Then you reach some saturation, and number of involved people flattens out. And then when you finish some particular stage again, not all tasks can be finished at the same time. Number of involved people decreases in reverse curve. So somewhere here work is almost done for a particular project stage, but then there are different kind of tails to be cut, etc. for this project, and it looks like this. Of course, this is not said that it's absolutely symmetric, but this how number of involved people for some project or stage of project looks like if this number is large enough. And then of course, if your number of people in your company or whatever is this, and you have to provide useful work for everybody of them, these people who start leaving this stage of project, they have to start in next stage of project. And so total amount of people involved is all the people in the company or the project or whatever. But then when some of these people leave this stage of project, they start joining that stage of project. And what is consequences of this is that if you start working in any random project, because this flattened stage usually is longer than initial stage and final stage, probability is much higher that you will not be first person in the project and you will not be the last person in the project, because most of people are working in this project not from the early beginning, but somewhere here when this project ramp up, let's say somewhere from here till to here. And then there are only few persons who actually initialize this project and only few persons. And if you show this in this Gantt diagram, which will analyze for your practical task, so you see here is bar of first task. It goes from here till to here. And for this cyan task, you see that this bar overlaps. So there are concurrent things happening, but only for large scale projects, when you actually can see that some people start working in another stage of project where some other people still work there. But if this number is very small, then what actually happens, you always work only on particular task. One task is here, next task is after this first task is finished. So, and why waterfall is still used and what is good thing about it? First is that in this waterfall approach you always know effort needed and that also means costs and expenses, etc. in advance, in ahead of time. So you start working on next stage of project only when you have finished previous and you have calculated. So this means these are very predictable if they are successful. If they are not successful, they are very predictable until they very suddenly break apart. And also because usually each of next stages tends to be more expensive than previous stage. It's not so radically more expensive than for real construction, like when you build cars and bridges, but still it happens in a following way. And therefore you do everything in advance and prepare in advance to be ready for next stage, and you never go back. You always go only forward. And because of this predictability and predictable costs in advance, waterfall is still used in large-scale projects when you need to know costs in advance. And very popular approach here is for government institutions, local government institutions, because they have to plan their budget in advance, at least in 1 year ahead. What is not so good about waterfall is that quite a lot of important decisions have to be made here in early stages of the project. And as I say, any decision which is left for later time is good decision, because when you have more experience, more information, more time to think about this, then making this decision is easier. But if you have to force your customer to make important decisions in very early stages of the project, and the customer will see actual software after months or even years, then of course this is huge drawback. And therefore, so that is a bad thing about waterfall approach, because many things have to be decided very early in the project, and forcing your customer to decide about something is very hard. And particularly Accenture and MIT introduced another variant of waterfall model called V model. And if in V model, here on vertical axis, we see only dependency on the tasks, so while time is going from left to right, you go only from top to bottom with these completed tasks. But in V model, vertical axis or y-axis represents something different, not just dependency, because dependency here is shown as a sequence or order events during time, but in V model it represents your focus or attention on technologies. And usually you start project with very high level concepts and blue dream about something, and you do not care about technologies at all. You just have this business idea, or customer has his needs, and these doesn't touch particular technologies at all. But then during first stage of the project, you go deeper and deeper into this technological stack. You go in more and more technical details. So up here means very general things, down means very technical things. And so when you start collecting requirements and create design of architecture of this software, and then you make detailed design and implement it, then you do not care about these high level concepts at all. You care about technologies, about infrastructure and only these technical tasks. And when you have implemented it, then you start testing it by units, by modules, and you start integration testing, system verification and validation in more details, etc. Then you do not care about this technical stuff so much anymore, but you start thinking on overall picture again. And then there are different kind of iterative approaches which goes into cycles. And one of these is this spiral model, when you start initial planning, collect requirements, do analysis and design, implement it. You can deploy particular version into production. And deploy means putting it into place. And place may be test environment, development environment, or production environment. Then you do testing, evaluate results, and do it again. Here, for such spiral models or iterative approaches, very important part is to track your progress between iterations to be sure that you are not going into infinite loop. And if you think it's very trivial, then you do not have enough experience. For example, in quite a few open source projects where I have participated only as a user or maybe sometimes little bit of contributor, not as a developer in most of the times, just as a localizer, like translating strings to make this product for Latvian language, etc. I have seen that quite a lot of projects think that, okay, we have a big mess of this project, we will rewrite it from scratch. Rewriting from scratch is actually infinite loop, because you had already working project which you think is a big mess, you start from scratch, and when you collect so many functionality for your new project as it was previous, again, usually you get one big mess. And what this big mess in projects usually means? Big mess in projects means that sometimes they are messy, but in most of times big mess means I can't understand every part of this project, and for every large scale project nobody can understand the entire project, so it is like a big black box for everybody, and which they confuse this mess. And other thing is, you do not rewrite project from scratch, but because of dependencies you decide to migrate it to latest and greatest versions of your dependencies. For example, you change your development framework version or framework completely, you change your external libraries you are using, etc. So this means in terms of deployed software, in terms of features, what this product does, you do not get anything new, but you still have quite a lot of effort to do just to get everything as it was the same, just with different dependencies. And what I have seen, definitely rewriting something from scratch is a very risky project. Switching to completely different framework, like for different graphical framework or etc., is also quite risky operation. And if you have studied something about software development projects already, probably you know something that the most of IT projects fail. What this fail means? This fail doesn't mean that you do not have any software at the end or whatever. Fail means following things: that one of important metrics for project quality and achievements is total cost of the project, time spent for this project, and quality of produced software. And I will tell in details what quality is meant later. So you have such triangle. And fail means that these projects didn't reach all these three most important or very important aspects of the software. So they didn't finish in time, or they didn't finish in predicted cost, or they didn't finish in predicted quality. And in this case, that would be, for example, they didn't implement all the needed features of this software. And as I say, anybody can manage project in a following ways that you can cover only two aspects of the project. For example, if you have fixed cost and fixed time, you can do it. You will never know what your quality will be, how much of features you will cover. Or if you have fixed unpredictable cost and quality, you will never know how much time it will take. And if you have predictable and fixed time and quality, you never know how much it will cost. But if you take all these three together as important metrics, and you say that successful project was in budget, on time, in predicted quality, then failed projects are approximately 70% of all the projects in total. And so if you work on projects which are projects right from scratch, or move to new framework, possibility that this will fail is approximately 90%, and by fail I mean don't mean that this project will end up with nothing, but I mean that it will not be in planned cost and planned time and in planned quality. And new framework, let's say approximately 80%. So that's about these infinite loops, that it should be some kind of spiral when each of iterations is somewhat better than previous iteration, and if it's not, then you can just chase each new framework available for these applications. You can chase each new language version for this, etc. But as a real output which is deployed in production, there will be no any benefits for this project at all. So, and for this iterative approaches, very important part is prototypes, and prototype is some part of application which does one important thing, doesn't do anything else. And you do use prototypes first to test feasibility of your approach, that it may work. And first you use prototypes to show something to your customer, because to decide A and B, if A and B are different prototypes, for customer is much easier than to say in advance how exactly customer wants it to look like, how exactly customer wants it to behave. And you can do prototypes quite easily with modern development environment. So you can start from small, you can test it out. If it doesn't work, you can leave it and you can try different approach. And around year 2000, many of these iterative approach proponents published so-called Agile Manifesto. What they also stressed here in their idea is that beautiful code is not the most important part of your software. If that would be, nobody would use Microsoft Windows as a leading operating system. Nobody would use any other tools which are not great, because what is more important about this code, which is probably not the great, actually works, actually provides some value to the customer, and it solves some particular needs of the customer. And of course, Microsoft used different kind of monopolistic tricks and approaches to convince customers that its solutions are better than they actually are. So that's different part of story. But the most important thing for software to be used and for software to be developed is to cover needs of the customer or user. Customer is paying user, and user is just a user, maybe paying, maybe not. So you have to know what needs of users are, and if these needs are fulfilled and covered, then that is much more important than beautiful code. And Linus Torvalds, which is inventor, developer of Linux kernel, also used to tell that ugly code which works always beats beautiful code which doesn't work. And in this case, work means, fulfill needs of user. And also, what they stressed is that collaboration with your users or customer is very important, because only in such way you know what actual needs are, how to fulfill them, and that responding to change is much more important than precise plan. And here are some of these principles. For example, don't try to get everything beautiful, apply Pareto principle, like cover 80% of needs, which you can cover just by 20% of effort. Focus on high-level requirements, develop small incremental releases and iterate, etc. And then there are quite a lot of different agile methods in the world. Most popular, I think, are Scrum for development and Kanban for maintenance. And what is Scrum? Scrum is one of these iterative approaches when you may review and redo already developed software because you can. And the idea here is following, that long-term plans are hard, and even if you have a plan, it doesn't mean that it is feasible and you will actually work according to the plan. So all large projects are split into small parts called sprints in Scrum, and these sprints are very short, either a week, 2 weeks, 3 or 4 weeks, definitely usually not more than 4 weeks. And for these 1 till 2 few weeks, you have this product backlog, where it is just a list of issues, what needs to be done for this developed software. And of course, in most cases, in larger projects, you have dedicated issue management system for that, which can be called issue management system, bug management system, or whatever. And then for each particular sprint, you take out some of these issues which you think you can deal with in one particular sprint, and then you take only so many these issues which you definitely know that you will do in one sprint, and then you work on them. And the idea here is following, that all these issues taken out from this product backlog can be developed in parallel, in concurrent mode, and that you take only so many for particular sprints that it's never late. You always finish them, because for 1 or few weeks you could plan more or less precisely how much things you can actually do. And then when you finish it, you review previous sprint and you plan for next sprint. And most important roles for sprint project is product owner. And this, if you write product for shelf, like for many customers, for example, typical example is Microsoft Office or LibreOffice, which is used by many users, then this product owner is like from your company. If this is a unique project for some particular customer, then this product owner actually may be representative from the customer. So, and this guy is responsible for overall development of this project. In your team, product owner probably will be this guy who come up with idea on which thing you will be working on. Then there is Scrum Master, which is responsible for this Scrum team, that every member of the team is productive. You may think about him or her as a manager, but remember, every time different ideologies and schools invent new term, they invent this new term to force these differences from other project methodologies, and therefore they call it Scrum Master. Again, master is considered for social justice warriors offensive term. No idea how it could be called with non-offensive term for some snowflakes. And then there are development teams, and depending on size of the team, you probably will not need very great specialization, because as teams become larger and larger and larger, as more specialized members of the team needs to be, otherwise they just disturb each others and step in foots of others, so they cannot work productively. But in general, everybody of you will probably be developers. Some of you may also be more dedicated quality assurer or tester or documenter or whatever. These usually are these guys who are not so technically skilled, so good way for them to contribute is to emulate users of the software and document software for these probable users. And probably one of guys may be more dedicated also to configuration management, to deal with things like version control repository, building approaches, deployment approaches, depending on what kind of software type you are developing. And so why this Scrum Master is not called manager but master? Because Scrum Master is responsible for this team to be productive, but Scrum Master do not give orders to the members of the team. Because in old school management approach with waterfall model, idea, at least in theory, as a ideal principle is that you have precise plan, and this plan is so precise that even monkey can do it. And so there is this manager which gives orders to these monkeys what they need to do in the day, in next day, etc. But in Scrum, nobody gives you orders. When you plan for Scrum, you create an issue list. So you take this product backlog, which is like 150 different issues you have to develop during entire project. Then you take like 30 issues out of them, and everybody who is free may work on them. And in ideal case, all these issues are independent, so you can start working on them in any particular order. In practice, there are usually some dependencies. You have to start working on these 5, 6, 10 issues, and then you can go to other. And team members just declare, I'm working on this issue now, and other team member says, I'm working on this issue now. So instead of push orders to monkeys, these monkeys are smarter than that they pull these tasks by themselves. And this, I think, is very important idea of management, that one of Murphy's law about project management says that under pressure, situation worsens. And giving orders to somebody means that there's only one responsible guy who is responsible for overall tasks to be done. So it adds some pressure to this one guy, and it also adds pressure to these who have to follow these orders. They may disagree, etc. But if for Scrum Master, his or her responsibility is just to make team productive, and one of the things is that there always should be buffer of issues which needs to be done, and then these team members just take them or pull them out of this issue list, it works much more easy on everybody. And what is also important is that if there is this poor guy who just pushes orders to these monkeys, if this monkey finishes this task earlier, usually what happens, this monkey browses internet and whatever, because there was no other orders given to him or her. But if this monkey should be smarter, if then they do not, team members do not afraid to work on different scale of problems. For example, one may decide to work on problem which takes several days to complete, and he or she knows that he or she will take new problem to work on only when this previous is ready. But these who are different mindsets, they can work in one problem in 1/2 day, done, take next, etc. And this means that you do not have unproductive time. Everybody works as much as he or he can to work on these projects. Of course, if you are tired and you need to take some rest or break after that, you are not required to work like in gold mine in old times. But so idea here is that if you manage your own time, all the members of the team are much more productive. And therefore, these are called Scrum Masters, so they do not push orders, team members pull these issues, and only thing for one of responsibilities for Scrum Master is that there are always list of new issues on which members of the team can work on. And then another important part for Scrum approach is that when you think about intellectual work, like development, you need to prepare for it. And I like this analogy about deep diving. So if you are a diver, here is water, here is ground, and you need to prepare, I do not know, Nord Stream 2 gas pipe. And to start actual work here, you need to dive here 100 meters or maybe more just to get there, and only when you get there you start productive work somewhere here. And if somebody interrupts you with some question, etc., you are taken out into surface here, and you need to prepare and deep dive here and to do. And for intellectual work it means following. You have complicated code here, and you need to understand why it works differently as you want it to work, etc. You have to prepare you for these data structures, for calls and logic, how it works, etc. You need to create model of your software to understand it. Of course, I try to avoid to do this as possible because I think it's devil. I usually do debugging and testing instead of understanding everything. But one of approaches, of course, you still need to understand where to debug, etc. And if somebody just interrupts you, your mental model breaks here, and you need to prepare your mindset for this problem again. And as more complicated this problem is, this means as deeper you need to dive into this problem, as more time you need to spend to become productive. So interruption may be just few seconds, but then you lose. So here is interruption, but you lose some time by preparing your mindset, and only then you can get productivity back again. And because of that, one of important parts about Scrum is that there are no, until there is no fire alarm or whatever, there are no unplanned interruptions between team members. You have only planned meetings on planned time, and to make these meetings as short as possible, everybody who is not disabled have to stand up and stand on their legs. And when you are tired of standing, the meeting should be ended. And then after that, there are no unplanned interruptions. And I think this is also a very important idea and aspect of the Scrum. And then you check how many of these issues you have covered so far. If issues are well planned, then there are no issues which are much more complicated than others, because then you always can split some larger issue in smaller ones. So here is number of issues you want to cover in particular sprint, and you check, for example, that gradually you are going on time to cover them up. And then you have this backlog, which is history of your entire project during several sprints. And particularly for maintenance projects, which also use more modern project approaches, I think Kanban is the most popular one, but I will not cover this in detail. In Kanban, important thing is that every issue is much more complicated than in development. In development, usually only one single person works on one single issue. But in maintenance, typical thing is that, for example, you will start working as an intern in Accenture. It is an issue, but to solve this issue, there may be many persons involved, because you need to get your badge to access building and room. I do not know how it works now with this remote work. Then you need to get access to information systems. You need your login, username and password, and access to different other resources. If you work in office, you need laptop or other computer. I think today these are mostly laptops. And desktops are used only when bigger performance is needed. Then you need like desk and chair, etc. And there are many persons which need to be involved to solve this issue, like new intern is coming. And then of course in particular project, they need to prepare and know what you will be doing and what your role will be, etc. So in such maintenance projects, issue have internal life cycle, and they go through it when different persons are doing different parts of these issues. So that is very different from development projects. In development projects, issues are simple and can be solved by a single person in most of cases. But in maintenance and larger projects, issues have their internal life cycle. They go from step to step to step to step. And then in large-scale projects, they use good thing in both of worlds, like waterfall or V model, and iterative approaches to not go into infinite loop. In large-scale projects, some kind of waterfall or V model is still applied to not lose track of your initial goal. For example, if project takes more than 1 year, then still in general terms, it will be planned as with waterfall approach because of this predictability, knowing costs and time in advance, etc. But then inside these more general stages, usually they split large projects in smaller teams and they work in these iterative approaches. One other thing is that usually Scrum is used in small sized teams, like team shouldn't be larger than what you can collect in one room. Or some of these proponents of Scrum told that if you can't buy pizzas for your team and make pizza party, then probably your team is too big, so it should be split in smaller parts. And so there are two different schools and approaches for these linear approaches like waterfall and V model, and agile approach like rapid application development, Scrum or whatever, and they both have their benefits and drawbacks. So in traditional project management like waterfall, you concentrate on precise plan and plan everything up front, and you need to have very high predictability to be sure that this plan can be completed. But in these agile approaches, you are not planning so precise plan, but you are planning what you will do next, how you will respond on changes. And I like to compare these two approaches with physical world, like two different technologies which can be used to blow up some city. So older technology, which is of course rocket science and high tech, was ballistic missiles. An idea here is following, that you shoot up a ballistic missile very precisely, so you plan here everything, resistance of air, rotation of earth and winds, etc. And you do very precise planning and you shoot up this rocket here, and after this very short stage of combustion, after that this is just a dead weight which travels in suborbital orbit around the world, and it may hit in approximately 40 minutes any part in the world in this precision with a few kilometers, let's say 1 kilometer in precision, so you can blow up some city with nuclear missile quite easily. Okay, let's write precisely 1 kilometer. And that would be something like waterfall or V model. So everything, but waterfall I think is better. So you just plan for everything and then you just follow this plan. But then there are other kinds of missiles, these guided missiles, which are guided all the time while they are traveling. And then precision is much bigger. You can shoot this missile in the window of Saddam Hussein's kitchen. And for such guided missiles, not ballistic missiles, how do you shoot it up? Doesn't matter. You just shoot it up in any direction because it will guide itself around radars and around mountains, etc. So here is much more important that you track progress of this missile and you adjust to it till to the very end of the project. So initial stage is not important, but tracking your progress and adjusting to it is crucial. And that would be, let's say, Scrum. And if you will not track it precisely, etc., then of course your guided missile will just go into some infinite loop and will drop somewhere, who knows somewhere. So Scrum is something like guided missile. It requires much more requirements from your tools and skills, but in the end, if you guide it precisely, your final result will be much precise and much more predictable than with this waterfall approach. So that's about these things. So then, particularly Accenture, because it works as a consulting company which also provides solutions and developed by themselves, they market their skills and knowledge about different approaches quite extensively, and they have, at least they had, their marketed approach called Accenture Delivery Methods, and in general probably you have heard a term called best practice. So best practice is different collection of approaches what are considered during time that this is good way how to do some things. And Accenture Delivery Methods is something like collection of these best practices. How can you work on different kind of projects in different cases, which hopefully will provide you biggest possibility of success. And important part of this practice, of course, are different kind of technical tools to track your progress, to deal with issues, to manage configuration for development and testing sites and production, etc. And so idea here is that everything which can be automated, everything which can be done by tool, not by human, is good, because tools are more predictable, they do not get tired, they do not get sick, etc. Particularly recently, probably you have heard, for example, DevOps as a term, which is joined two terms together, developers and operators. And operators are these who operate with systems like maintainers and or users. So DevOps means approach when you automate like tasks, putting software from development stage to the production stage in very automated way, which is less error prone than different kind of manual procedures. And when I worked in Accenture, that was of course quite a long time ago, we had internal website kx.accenture.com. It was internal, so not available from the internet, but only from intranet. And it was a wiki site with all these things. And that wiki was Microsoft SharePoint portal server, which is proprietary wiki system. And so it was full of different kind of pages and links to search information for different kind of projects and to get help about that. And then regarding to quality assurance, there are two important terms which you probably should know, at least Accenture thinks that you should know what V model is and what verification and validation is. So verification, as I told you, is maybe called testing, but it is more detailed and precise testing, because in verification you check for consistency. And general question you may ask during verification is, are you doing it right? Do you follow best practices? Do you follow these best practices consistently? So consistency is the most important part of verification process. Why consistency is important? Because if you are not consistent in your project, you can forget many things, you may misunderstand many things, etc. So, and consistency means the same approach during entire stage of the project. So, for example, formatted code is also part of consistent approach, that everybody uses the same formatting rules in the project, everybody uses the same configuration environment, everybody uses the same approach to compile, debug, etc. And validation is more specialized process. In general, it is question: are you building it right thing? For example, you have so here is with V model with more detailed stages, collecting requirements, design, detailed design and build, then component test, assembly test, product test, user acceptance tests, operation readiness tests. So when you verify, it is self-reflective. You just apply general rules or common sense to it. And if it follows common sense and general rule, then you can pass verification stage of the project. But validation looks on output of previous stage as output of the next stage. For example, if you have collected your requirements, like functional requirements, what software should do, and technical requirement, how it should do it, then you check that the design covers all of these requirements. When you start building, you check that everything is built and implemented according to this general design. So for validation, you go for more specific details. If somebody of you completed extra exercise about XML validation, then you should know that validation means that you need XML schema or DTD schema to validate it against something. So you can verify that XML is not broken, it follows general rules of XML format. That would be verification. But if you want to validate your data structures, you have to have precise instructions how these data structures should look like. So that is validation. And then important part of development process is checking for quality. And quality in general is conformance to requirements. If requirement is that it should be cheap, and it is cheap, then it conforms to requirements. If requirements are that it should be expensive, only rich persons can afford it, and it is expensive, then it is quality, conforms to quality requirements because it conforms to the requirements. And particularly for software, quality means that first the system doesn't crash, because usually you do not have requirements that it should crash frequently. There is correspondence or link between how software works and what are user expectations. Performance is in specified requirements, and quality must be controlled, because if it is not controlled, then usually it becomes worse, because in any large system, in any large project, sooner or later, everything falls apart, and therefore you need to make some effort to do this. And particularly for large-scale projects, when different kind of vendors propose their proposals for customers, one of problem with specific unique projects is that this is specific unique project. Nobody has done something like this before. And of course this is a larger risk for the project, that it may fail, and by failing I mean will not finish on time, in planned costs and on planned quality. And how to deal with this problem is following: that similarly to other activities and areas, they use badging system, and badge means probably most of you have heard International Standards Organization, which provides different kind of best practices and standards how to do things, and one part of these standards is about quality of production of these things. And one thing about this quality assurance is that if you are doing everything right, probability that your final product will be right is higher than if you do everything wrong. And similarly to software development, so assumption is, and it's quite good assumption, but it's only assumption, that if you do everything right, then probability that even for your unique customer project, which has never done before, it also will be right at the end, because all these smaller steps are done right with best practice, etc. And for customer to know your skills and knowledge before this project, you have to earn these badges, like these quality ISO quality standards, where your previous performance is rated. And some organizations also in software development follows these ISO quality standards, but there is more specialized badging system called Capability Maturity Model, which is intended especially for software development and maintenance. So not for construction and building, not for anything, but particularly for software development. So when you bid for customer and when you try to get ahead of your competitors, one of these is your badge, which you have earned from your previous projects, how well you have done these previous projects which were investigated. And so how it works in the following way, that you pay money to external auditors, which audits your all projects, previous projects, current projects, and they rate you how organized you are, with the assumption that if you are better organized, then probability that you will finish your projects on time, in budget and in required quality is higher. And that, of course, this is true in most cases. So you pay to these external auditors, they audit your company, and then you can get different levels of CMM badging system, and 70% of audited company gets level 1, called initial, and it means following: if your project was success, that was luck; if it was not success, it was just bad luck. But if you get level 2 badge, it means you can repeat your success. So you deal with configuration management, you do quality assurance, you do project tracking and oversight, you do planning for projects, and you manage your requirements of your software. Then you can get level 3 badge, which means defined, and this means, in general, it means everything is described. You can always find information how you should do something. You have peer reviews, integrated group, coordination, product engineering, procedures how you engineer your project, integrated software management, training programs for beginners, definition of internal processes and focus. And this level 3 is comparable with ISO quality standards. And then level 4 is managed, software quality management and quantity process management. And quantity here is very important, because one of ideas of quality management is that you cannot manage quality without measuring it. And measuring means assigning number to it. And you assign numbers in different ways. For example, how many new opened issues were when you released your product, how long these issues remained open without resolving, how much time did you spend to solve this issue, how much time you spent to develop this software, etc., etc. And level 5 or optimizing means that you could prove to your external auditors that your processes with these numbers you can provide to these auditors shows that you are improving, that in previous year your numbers were lower, where lower means worse, and higher when higher means better. So you can show with these numbers to external auditors that you are improving. In general, Accenture has projects, I think, somewhere in level 4, that everything is managed, but for particular projects they have got the CMM badge from external auditors that they are actually optimizing their processes. So that's about quality management. Now a little bit about designing of your software. There are two different approaches how you deal with particular issues and how you develop things. With waterfall model, you start with general things, then you design, and then you develop. And one of problems why such projects may fail is because when you start developing, you see that this vision or design was flawed. So it cannot be actually implemented in such way. So you are stuck somewhere here. In V models it would be somewhere in the middle of the project when you start dealing with all technicalities. So that's bad. Therefore you can do absolute opposite approach, like for iterative approaches you start solving small technical problems, you create prototypes, and then you put them together, and then you reuse them and create system. So, good approach for this iterative approaches is that you will never be stuck in some technical difficulties because you started with them and you tested them out and you checked what works, what doesn't work. Problem is here at the end of the project when you need to put things together, then you find out that all these small prototypes were developed in different environment, in different frameworks, different dependencies. So you can't put it together and you may fail here to create a complete set of your software to put everything together. And therefore, in general, this means that depending on what kind of difficulties you have, you always should remember this top-down design to not lose this general vision and direction of development of your software, but sometimes you need to pay attention to these technical difficulties, to these small things, and depending on which particular stage you are, you may switch your focus from top-down design or bottom-up design. And you should always remember that depending on what kind of difficulties you have to pay attention and to solve these things into completely different approaches. Sometimes you need to pay attention to general vision and general things. Sometimes you need to pay attention to small things and then put these small things together. And here in this slide there is different kind of roles which you may find out in software engineering. And software engineering is many things together, everything around the software development, maintenance, migration, integration, etc. And how do you need to read this picture? On vertical axis here you see responsibility of involved roles in project. So in lower part you are responsible only for yourself. In upper part you are responsible for many persons in organization. In horizontal axis to the left is more technical roles, to the right are more people-oriented roles. And blue means more like developing things, which means change things, probably break them and fix again. And green means operate things, which means usually deal with reach for stability. So developers need changes because they are paid to do changes, and operators don't need changes because they are paid that everything works. And change to the worse is very bad change. And usually when you start internship in Accenture or any large company, you start, for such bootcamp, you start with technical role and you are only responsible for yourself. If you are skilled enough and you can immediately start contributing to Accenture like a developer, you start as a coder. Where is the difference between developer and coder? For these previous 2 weeks you worked as a coder because you didn't do design. Design was forced to you by somebody else and you had to implement this already given design. Developer is guy who also is responsible for designing some part of it, not everything, because there's also like role called systems architect who is responsible for entire architecture of some kind of solution. If you are not so skilled, you may start like a tester or quality assurer, and here these roles quite typically overlap. Tester is more technical and quality assurance is less technical, like in quality assurance you pay more attention on particular requirements. In testing you pay attention more in technicalities that it actually works, etc. If somebody has decided to change his or her career and they still have great knowledge in some other non-related IT areas, they may start with so-called subject matter expert. These are guys which are working in Accenture, but their expertise is in some other industry, like buying, selling things, manufacturing things, government, local government institutions, healthcare and Medicare and military, etc., etc. But usually you start somewhere here, technical role, because you are trying to be Java developers and not much of responsibility for everybody else. Then there are more diluted roles, more general roles like system analyst and functional analyst. These are, I myself think about myself as a systems analyst, not as a developer, because I manage projects, I collect requirements, and then it just happens to be that for some part of the project I work as a developer or coder to implement these things. But so, in general, systems analysts are these guys who are not so specialized in tools and code itself, but are somewhere in between these customers and developers. Then there are this new role in Accenture and other projects, DevOps, which is somewhere in between developers and operators, and operators are actually called administrators in most of cases. There may be just administrators, they may be more specialized like network administrators, database administrators, domain administrators, etc., etc. And then in Accenture, as in any large company, as I told you, in large companies, they don't need jack of all trades persons, because if you cover too many things, for example, in large company, if you cover many things and you have many persons, their expertise overlap each to other and they disturb each other. In large companies, you'll like specialists, which are specialized in particular areas. And particularly in Accenture, they look on your career in two different paths. So you start like an intern, but then you have two different options. Either you specialize and you go deeper and deeper in your technical skills, and of course, depending on your responsibility, if you are systems architect, you still need to know quite a lot of things about general things, or there is management path. So when you get some expertise, you may decide that you do not want to go deeper and deeper in different kind of tools and frameworks and these things, but you take responsibility of other persons. So you become Scrum Master, then department manager or whatever. And so these are two different choices in Accenture what you can do. So one is you become more and more specialized, and of course, depending on size of project, you may also be not absolutely specialized in things. You may cover different things. For example, for mobile platforms, as I told you, most of users and customers do not distinguish between these completely different platforms like iOS and Android systems or phones. Therefore, particularly for mobile platforms, usually they tend to teach all their members to be able to develop it for both for Android systems and iOS systems. Or you can take more and more responsibility and you can start managing other people. So first you become team lead, or if this team is working with Scrum, you are Scrum Master, and then you take more responsibility and you are responsible for other persons as well. And as I told you, particularly in your teamwork, everybody of you should be a developer. Then you may need to specialize a little bit about testing, quality assurance and configuration management. And also you will need to decide, for example, who will be your Scrum Master and this product owner. And now a little bit about state of projects. Some of you may not have great experience in teamwork yet and in software development projects yet, and you may get disappointed. And what is important here is that there are many people who like challenges, like climbing in high mountains is not fun, at least during climbing. It may be fun later to share stories about this, but it's definitely not fun if you try to reach quite high mountains when you are doing this. And development and intellectual work in general is also something like climbing up in mountains, but instead of doing this physically in cold and whatever you have these environments, you need to do this intellectual work. You need to think hard, you need to solve problems, etc. And it's not just like a fun what you can see in Hollywood movies. And therefore, here is example of one real small-scale project. How do you feel about this? For example, you start with some excitement and then your excitement just goes down and then you recover it a little bit. And that's how it usually looks like. And if you generalize it, and I always like to generalize things, I like to be generalist, not a specialist, then I think there is similarity between this practical observation, how does it feels, with Hype Cycle, which has even a Wikipedia entry about it. And Hype Cycle is invented, I don't know by who, but it's about expectations of some kind of technology about some kind of solution. Usually when some silver bullet is developed, everybody gets very excited. You get peak of inflated expectations, and then it goes through this illusion because you find out that this is not silver bullet, it is just yet another approach to do something. And then you recover and go to this plateau of productivity. And I think that this V here is part of that V, because for smaller scale projects, this peak of inflated expectations is very short, so you start immediately with very high expectations, and then it goes down, 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 and then you recover, and then if that project would be longer, you would get into this plateau of productivity and plateau of feeling not very bad about it. But if it is very short project, like 1 or 2 weeks, you end up here, and then your project ends up. So that's about these things. Another thing, of course, is here you are working as a in project with volunteers. And problem with volunteers is that you do not have any carrots or sticks to give to your team members. So that means you need to share this your common goal in such way that everybody is convinced that this is good approach. So therefore my recommendation is to remember that every of your team member is volunteer there, and to get best out of volunteers, of course, you should discuss if it's needed and manage your workload in such way that everybody feels not very bad about this project. As I told you, for any intellectual work, you may get tired about this, but that everybody in this team is productive and have his or her place where he or she may contribute in the best possible way. So that's about software project management in short. Do you have any questions or comments on that?